All right, we're going to go through the Chapter 3, Algebra 2 Chapter 3 review. I'm going to start off with the page about graphing. As we talked about in class, there's two different forms, so we're going to look at the standard form and the transformation form. You can always identify the transformation form by looking for this x minus or plus something squared, right? So you're always going to have that like parenthesis with the square around it like that. So these first two, numbers 1 and 2, these are in standard form where we just have the x squared, the x, and the constant term. So let's start off with number 1. Number 1, we have our x squared term, and then the next term that comes after it is actually not the bx term, it's the c term. This is one of those ones where the b value equals 0. So our a value here is 1 because there's a 1 in front of the x squared. The b value is 0 because the bx term is missing in the middle. And the c value is -5. All right. Anytime you're graphing in standard form, the very first thing you're going to do is you're going to find the vertex. And the vertex can really only be found by using this nifty little formula, which is that the x value of the vertex will be equal to -b over 2a. And that's from our b value and our a value here. So in this case, since our b value is 0, that would be -0 over 2 times 1. No matter what 2 times 1 is, 0 divided by anything is going to be 0. So our vertex for this question is going to be at 0. Now, the only way to get the y value for the vertex is to plug in that x value. So you're going to go back up to the equation y equals x squared minus 5. And in for x, we're going to put the value of 0. So 0 squared minus 5 means that the y value would equal -5. So we'll go down to 0, -5. We're going to plot a point. That point is your vertex. I like to mark that as your vertex so that you don't forget. We also know that a parabola has symmetry. So I'm just going to draw this dotted line here on the y-axis. That represents the axis of symmetry. That axis of symmetry would be x equals 0. All right, now normally we would plot our vertex and then we would still be able to plot our y-intercept. But the problem here is that the vertex is the y-intercept. So for the rest of the points of this graph, we're just going to have to plug in random values. And as we talked about in class, the best values to plug in are x values that are close to the vertex. So since the vertex's x value is 0, we should plug in x values that are close to 0. So we could plug in 1 and 2. And this is a pretty easy equation to plug these values in. So when x equals 1, that means y equals 1 squared minus 5. 1 squared minus 5 would equal -4. So we can go ahead and plot the point 1, -4. And we can plot the reflected point on the other side. And then if we do x equals 2, that would be y equals 2 squared minus 5. 2 squared is 4, so 4 minus 5 would make a -1. So then when x is 2, y is -1, and we can plot, once again, the reflected point on the other side. And that gives us our parabola. All right, we can fill in a few pieces of information down here. So the vertex there was 0, -5. The axis of symmetry was x equals 0. The y-intercept ended up being exactly the same as the vertex. And then domain for parabolas is always -infinity to infinity. That will never change. But the range will always be restricted, so you always have to look and see. Remember that the range is low value to high value. So our lowest value that we achieve here for our y value is -5. And then because this parabola goes up to infinity, we end our range with infinity. All right, now that wasn't so bad because the b value was 0. Calculating the values that we were plugging in wasn't a big deal. Now number 2 is not going to be quite like that because the b value is 4. So we can start off exactly the same way. So our a value is -1. Notice the negative in front of the x squared. that would be your negative 1 there. Your b value is positive 4, and your c value is negative 6. So we're going to start off by finding the vertex again, and the vertex has an x value that can be found by doing negative b over 2a. So that would be negative 4 over 2 times negative 1. And if you simplify that, that would be negative 4 divided by negative 2, which would be 2. All right, so our x value for our vertex is 2. We now need to plug in x equals 2. So we can do that by going back up to the original equation. So now this one's an interesting one on the x squared here. Because that negative is already there, we're just going to put that negative on the outside. Then the 2 gets plugged in for x. I want you to be careful here that you don't attach the negative to the 2. It's the x value is 2, and that 2 will get squared, and then the negative will get attached at the end. Then plus 4 times 2 and minus 6. So the 2 gets squared to make a 4, and then the negative gets attached to that 4. Then the 4 times the 2 is 8, and then minus the 6. So that would be 8 minus 10, which would be a negative 2. All right, so we got our vertex is 2, negative 2. It's going to be right there. Our axis of symmetry then will come right down through that vertex. That vertical line is the line x equals 2. All right, now this is great because this time, because our vertex is not on the y-axis, we will actually have a y-intercept that is not the vertex this time. And you might remember from class that there's a really simple way to get your vertex in any parabola, really. Well, specifically in standard form. And that is to plug in x equals 0. But when you plug in x equals 0 to this equation, you would put a 0 here, and you would put a 0 here. Well, both of these two terms would cancel out because of that 0, which leaves behind just the c value. So don't forget that the y-intercept for any standard form equation will always just be 0, comma, c. So we can go straight down to negative 6 here, plot that point. We can see that that's 2 units away from the axis of symmetry, so we need another point 2 units away on the other side. Now, that's actually enough points to have a pretty good picture of what this parabola looks like. We've got our vertex, we know the shape of a parabola, we can kind of draw a rough sketch, and you don't really need to get any more points than that. That's pretty good. All right, so our domain, just like normally, it goes forever to the left, so that's negative infinity. It goes forever to the right, that's positive infinity. And then our range, once again, our range is down to up. So this time our down value, this thing goes down forever, so our down value is going to be negative infinity. And then the highest up that this thing can go is right here at a y value of negative 2. So we'll use a bracket there on the negative 2 to show that the graph actually equals negative 2. All right, so anytime you graph something with in standard form, the main things that you're going to work on are finding the vertex using that negative b over 2a stuff, and then plotting the y-intercept using 0, comma, c. And then you just kind of have to see where you are after that. If you need to plug in another x value, you can. But if you already have enough points and you don't need to, then you can just be done. Now, when you shift over to transformation form, you have to change your approach. The b value and the a value are totally different in the transformation form. And not only that, but in transformation form, you have to start with a parent function. And so that parent function will always be the same. The parent function for a parabola starts off at 0, 0, 1, 1, and 2, 4. And also the reflected points, so negative 1, 1, and negative 2, 4. All right, so what we're going to do is we're just going to go through and we're going to make the A, B, H, and K value changes. All right, so the A value here would be the number that's multiplying on the outside, so that's going to be -1/2. The H value is the number added or subtracted on the inside, but remember it's sneaky, right? So it's the opposite of what it looks like, so that's going to be 3. And then the K value is the number added or subtracted on the outside, so that's going to be 4. All right, so the A value, all we do with the A value is we multiply our Y values by that number, so -1/2. All right, so I'm going to use red to represent our new points. All right, so I'm going to start on the left side. The Y value of this point is 4. So we're going to do 4 times that -1/2. 4 times -1/2 is -2. So this point is just going to move to a Y value of -2. All right, the next point up has a Y value of 1. That Y value, so 1 times -1/2 would be -1/2. So this point is going to move to a Y value of -1/2. All right, the vertex here has a Y value of 0. 0 times -1/2 is still 0, so that vertex is going to stay where it is. And then you can kind of see that these points are going to be reflected on the other side. That one's going to be at -1/2. This one's going to be at -2. So what happened? The graph flipped upside down, and it got shrunk vertically a little bit. All right, now we don't need those purple points anymore, so this is our new parabola, but now we have to do the H and K value changes. So the H value change, it looks like it's going to be a -3, but it's actually a +3, so that's going to move right 3. And then the K value is a +4, so that's going to be up 4. So every single one of these points just move right 3 and up 4. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3. Then you got to count the halves here. So 1, 2, 3, 4. The vertex, 1, 2, 3, 1, 2, 3, 4. And then once again, just the reflected points on the other side. And again, once you get, if you're doing this with a pencil or whatever, once you get the last place where the points will be, you can just erase all the other points if you want to. All right, so vertex. Now, you might remember this from class. I talked about how you can actually do this transformation stuff a slightly different way. The vertex will always end up just simply being your H value and your K value. The axis of symmetry, once again, will go right through your vertex, so that would be x equals 3. Okay, your y-intercept here, we actually didn't solve the y-intercept yet, so we can do the domain and range. We'll come back to the y-intercept on that. The domain for any parabola is -∞ to infinity. The range here, down to up. Down would be -∞. Up would be, it reaches a maximum height of 4. And that's going to have a bracket on it. Now, we actually didn't have to get the y-intercept in order to graph it. But to find the y-intercept, all you have to do is plug in 0, right? So even though it's not easy like the standard form up above, you just plug in x equals 0 and you solve it out, and you can still get the answer. So that would be -1/2 times 0 minus 3 squared, and then plus 4. So 0 minus 3, that's going to be -3. -3 squared is going to be a +9. So then that 9 times -1/2, if we put it into a decimal, that would be -4.5 plus 4. So that would be -0.5. And you can see the way I drew the graph, actually, it does pretty much cross right at -0.5. So the y-intercept there, 0, -0.5. All right. Now, I'm going to show you another way to do this transformation stuff. Some of you may like it, some of you may not, and that's okay. All right? But you can choose to do it this way if you want to. So because we know the parabola's vertex will always just end up being your H value and your K value, What you could do is you could just right away identify your vertex by identifying your h and your k value. So your h value looks like it's a +5, but we know that h is always sneaky. So your h value is actually -5, and your k value is exactly what it looks like, so -1. So we 100% at the very beginning, we know that the vertex for this graph is going to be over here at -5, -1. So we've basically taken care of the h value and the k value, but now we have this a value of 3/2 that we have to deal with. All right. There's two ways that you can deal with this. One way is just to plug in values of x, right? So since our vertex is at -5 for the x value, we would want to plug in values that are close to -5. So we can do x equals -4, and we can plug that into the equation. So that would be 3/2 times -4 + 5 squared minus 1, and then just use our calculator, use our head to solve that. So -4 + 5 is 1. 1 squared is also 1. 1 times 3/2 would give us 3/2 minus 1, which would give us 0.5. So when x is -4, the y value is, excuse me, is 0.5. And then we can always plug in another one. We can do the next value over. So let's do x equals -3. Plug in -3. -3 + 5 is 2. 2 squared is 4. 4 times 3/2 would be 6. And 6 minus 1 would be 5. Once again, you can do this all on your calculator if you want to. So go over to -3, go up to 5. And then I never did put my axis of symmetry here, but it's 2 units away from there, so it's going to be 2 units on the other side. And then you get a nice looking parabola. You didn't really have to do transformations. You basically just plotted the vertex and then plotted a couple extra points. So our vertex here was -5, -1. That means our axis of symmetry would be x equals the x value of the vertex, so x equals -5. Our domain, as always, -∞ to infinity. And our range, this time our down value for range, the lowest this achieves is a -1 for a y value. And it goes to infinity upward. So that would be like that. All right, now we still have that problem of the y-intercept. So let's go ahead and plug in a 0 here. So when x is 0, we're going to put a 0 here, and we're going to evaluate this function. So 0 + 5 is 5. 5 squared is 25. And then 25 times 3/2, you can do that in your calculator. That would be 75 divided by 2. And then we'll subtract 1 from that. Well, 75 divided by 2 is actually 37.5. So minus that 1 would give you 36.5. So your y-intercept would be when x is 0, the y-intercept is 36.5. All right, so that takes care of the graphing, right? So remember, on the test, you're going to have to evaluate, is it standard form like this, or is it transformation form like this? Once you identify which form it's in, then you can do the right calculations or the right process for that certain kind of parabola. All right, the next video will focus on the next page of the review.